Okay, so we're going to be talking a little bit about some of our basic exponential functions. And a basic exponential function is just something where where I'm looking at a constant base to a varying exponent. Now, this is a little bit different uh, than your usual polynomials, where you would have, say, uh, your your base varies, but you'd have a constant exponent, like an x squared or an x cubed. So we're gonna here we're gonna find things where we've got some some value that is going to be taken to different exponents. So it's important to remember a couple of our things with our exponents. And there's a couple good rules to keep in mind. One of the most useful rules to remember is the zero exponent rule. And the zero exponent rule basically says that anything to the power of zero is equal to one. So that means if I had 2 to the power of 0, it's going to be 1. If I had 1/2 to the power of 0, it would be 1. If I had 45 to the power of 0, it would be 1. The other things to keep in mind are kind of the difference between positive and negative exponents. With a negative exponent, negative exponents take the reciprocal. So with a reciprocal, that means if I've got like a b to, say, a -1, that's going to be 1 over b. If I had a b to the -2, that would be 1 over a b squared. So things along those lines. Now that means that if I did a function that was, say, let's do a fairly straightforward function like y is equal to 2 to the x. And we're going to take a look at various values of x and y. And I'm going to go like -3, -2, -1, 0, 1, 2, and 3. And I'm going to do my scratch work over on this side. So here's where all of my scratch work is going to be. So if I did 2 to the -3, that would be 1 over 2 cubed, which is going to be 1 over 8. Okay, I got 1/8. 2 to the -2, well, that's 1 over 2 squared, or 2 squared is 2 times 2, so 1/4. 2 to the -1 is just going to be 1 over 2, okay, 1/2. We already said anything to the power of 0 is 1, and then, 2 to the 1 is just 2 by itself. 2 squared is 2 times 2, which is 4. 2 cubed is 2 times 2 times 2, which is of course 8. So looking at this, we see we see no matter what the exponent is, this never actually becomes less my value, even though the x can be negative, my value is never becoming negative. And if I were to graph this, if I were to graph this sequence, we would see a fairly simple progression, or we'd see an interesting progression where, you know, at negative, at like 0, it's at 1, at 1, it's at 2, at 2, it was at 4, 3, it was all the way up at 8, so 5, 6, 7, 8. Oops, here's my y and x. And then I go half, and every single time I go half what was there before. So what happens is I've got this thing that kind of gets closer and closer to 0, the more negative x gets, and then kind of shoots up at a fairly impressive rate here. Uh, this here, our x-axis is what we refer to as a horizontal asymptote because every single time this just gets half as big. A quarter is half as large as one half. This is one half as large as one fourth. Then I would have 1/16, 1/32nd, 1/64th, 120, 128th, 1/256th. So it's getting closer and closer to 0, but it's never actually getting there. So here we think of my x-axis as what we call a horizontal asymptote. It's a it's a line that this equation, this function will approach, but it will never cross. Okay, that's one fairly basic equation. Let's do another one. And this time, let's try something maybe just a little bit different. How about I do y is equal to, what would I do? 1/3 to the x. In this case, when I put together my table of values, okay, x and y, I do -3, -2, -1, 0, 1, 2, and 3. I'll do my scratch work over here again. 1/3 to the -3 is going to be the same thing as 3 to the +3, which is 27. Wow. If I were to take a look at -2, okay, 1/3 to the -2 would be 3 squared, which was a 9. 1/3, like I say, that negative exponent takes the reciprocal. So that's instead of 1/3 squared, we had 3 squared. Here I'm instead of 1/3, this becomes 3/1, or just 3. Anything to the 0th power is 1. And then anything to the first power is just itself. So 1/3 to the first power is just 1/3. 1/3 squared, that's 1/3 times 1/3 would be 1/9. 1/3 to the third is going to be 1/27th. And notice that I've got 3 and a 1/3, 9 and a 1/9, 27 and a 1/27th. So this, our 0 is kind of that reciprocal point. Kind of an interesting way to think about symmetry. But yeah, let's go ahead and graph these. And when I'm graphing this, let's see. Oh, it looks like I want to have some headroom here. So what is this? 10, 20, 30. Oh, wow. I'm going all the way down here. When I'm at -3, I'm at 27. So I've got 5, 10, 15, 20, 25, 26, 27, all the way up there. When I'm at -2, I'm at 9. So I have 5, 10. We'll go back 1, 9. -1, I was at 3. 0, I'm at 1. And then every step beyond that is a third of what I had before, where every step in this direction was 3 times what I had before. 3 to 9 to 27. Well, 1 to 1/3 to 1/9 to 1/27. So this seems to approach 0 a bit faster than our 1/2 did. or sorry, anything to the, I just had a larger base, smaller base. Ooh, whatever. Okay, y x, and let's just go ahead and the next one in that direction would be an 81 because 3 to the fourth power is 81. So so 1/3 to the fourth power would be, or 1/3 to the negative fourth power would be 81 up in that direction. Alrighty, and please pretend I can draw straight lines. So yeah, this is kind of what our equation would look like. So exponential curves tend to be pretty steep. And and in a lot of ways, you know, this is this is our basics. We don't really have a lot of new or different things that you're going to see with these types of exponential curves. Uh, Whenever you're dealing with this, just remember that you're plugging, if you're evaluating for any point, you're plugging in you're changing the exponent and not the base. Alrighty, that's all I've got for right now. We'll see you in the next video.